start with DLL hijacking, and just to, I know we kind of went over it in the PowerPoint just a little bit there, but I just want to give you kind of a graphical representation of what happens with it. All right, so what happens, is when you tell PowerPoint, let's say to open a PowerPoint document that's on a remote server somewhere, PowerPoint needs certain DLLs to do that. So it will first look in this remote share on this web server for those DLLs. And if it doesn't find them, what happens is then Windows will circle back to the local system. And on the local system, I believe it's, C, depending on the version of Windows, Windows System 32, doesn't matter if it's PowerPoint or not, it's a behavior of Windows in general. And this is how it was before Microsoft knew that there was a such thing as DLL hijacking. So what I'm doing is I'm showing you how the attack evolved, and then I'm going to explain to you what changes Microsoft made to Windows to make Microsoft core programs not do this anymore. Like PowerPoint, like Office and those other things, but it didn't change that behavior for third-party applications, if that makes sense.
I see. Okay.
Yeah. Thanks. So in the beginning, it was like this, and this is what would happen. So 99.9% of the time, the required DLLs to open PowerPoint would not exist on this remote store. So Windows would circle back, grab them out of a System 32 DLL, common DLLs, or some directory like that, right? And it would find the appropriate ones, feed those back to PowerPoint, put them in memory so that they can be used. And then essentially at that point, the PowerPoint document will be open. So that was fine. But then one day somebody said, well, what if I took a copy of the good DLL that's over here on the local system, and I copied that DLL to the remote store, would Windows now, in its step of going through the process of opening a PowerPoint, would it now grab that DLL and use that, or would it still circle back and go to local system? And the answer turned out to be that every time it would grab the one here, because that was considered to be most efficient. And also, if this were a third-party app and a developer were updating, DLLs and stuff like that, and updating all the pieces for this program, they might put it here versus sending it to Windows to eventually add into the, common DLLs directory, whatever the case may be. So this was just how we used to do things. So what somebody said was, okay, well, if that's true, then if we were to take that good DLL, all right, and then add some bad code to it, and then we put that DLL in here with the bad shell code, will Windows still grab that DLL? And it turns out it absolutely would. So what would happen then is we could now put a document, Word, PDF, doesn't matter, anything that you can open, put it on a remote store or network server, something like that, have you open it. And when you open it, you automatically grab our malicious DLL. So obviously there was antivirus and host-based intrusion prevention that would, do things like scan the remote store before it allowed you to open anything. So if you had a malicious DLL in there with shell code, it would scan it and say, oh, there's that DLL's got bad code in it. So yeah, we're not gonna allow you to load that DLL. So where the hijacking came in, the next step in the evolution was, now we wrote the exploit to where when you initially interacted with the directory, the DLL didn't exist there. The DLL only exists when you commit the act of opening the PowerPoint. When you open the PowerPoint or start to open it, then we would throw the malicious DLL in there. So now it is in the path, and then you grab it and load it kind of on the fly. And that's where the hijacking comes in, because we can't just store it there. Everything would find it. So now we let you start the process of opening the document, and then we toss that DLL in there, and you load that DLL instead of going back to system 32, getting the required ones. Now there are, if we go look on the internet here, show you just how recent it was for Microsoft to fix this. Okay, so on this list, all the way up to Office 2010 was vulnerable. Like here's the list of vulnerable programs. Let's get to Microsoft. And as you can see there, all of that list right there is Microsoft stuff under red. So, Visio 2010, PowerPoint 2010, these were all vulnerable. And some of the other Microsoft stuff is still vulnerable, things that are not used as heavily anymore now. Even the RDP client was vulnerable. Windows address book, like a lot of these are things that you don't think about. Somebody sends you a contact or a virtual card file and you add it to your Windows address book, you could be done just from that, because that's vulnerable. And it's a huge list. You should take some time to go through the list. What I used to do in some of the CTFs is I would say, okay, now that you know how to do DLL hijacking, go on this list, find any program listed on here other than the ones we did in class, and do a proof of concept DLL hijack against one of these programs. Like VLC Player, Wireshark, whichever one you want. Go find that program, download it, and then build a proof of concept demo of exploiting DLL hijacking there. So what eventually happened is we stopped updating this list. And when I say we, I mean the industry in general, because it turned out that there were more programs vulnerable than not. So someone started to make a list of programs that weren't vulnerable to it. Now, I do have a video for it. Let's see. I think if you just do DLL hijacking video on Google, yeah. So my video that I did back in 2011 is like the first hit you'll get in Google. So if you want to watch it, you can go and see it. I'm going to demonstrate it, but you can also go watch it. And you have a lab that you'll do with it as well here shortly, but it's not as laid out as the way that I'm going to do it. So let's look at a proof of concept of this, right? I'm going to exploit, well, let's just say Windows Live Mail, since that was in the list there. All right, so this is going to be my attacker machine. And we're just I'll use Metasploit to do it. It's easier to show it with that. I guess I should be in, actually this should still work. So the exploit in Metasploit is called DLL Hijacker. There we go. And we'll just use Meterpreter as our payload here. So I'm 166. So this is where you tell Metasploit what program or what application is you're trying to exploit. When you give it the extensions, it knows which DLLs to build based on extensions. Because if I did, for example, PPT and PPTX, then it would know that I'm trying to DLL hijack PowerPoint. So it would make the WebDAV DLLs for PowerPoint. I'm doing Windows Address Book, so I'm going to do P7C, virtual card files, Windows Address Book files, and GRP files, right? And that will tell Metasploit what programs we're trying to DLL hijack. All right, so let's look and see if I left out any required option here. All right, so I think I'm good. So now what happens is we launch the exploit and it says 80s in use. That's because I think I might have had a web server running from earlier. All right, so it runs and all it's doing is now it's just listening. So when you set up a client-side exploit, you're not gonna run an exploit and then you're gonna hit somebody. When you launch the exploit, it just puts your client-side attacker or your service in a mode that now if someone interacts with it, it should be able to exploit them or it will attempt it at least, okay? So now all we need is for the victim to visit this link, and now you have to think of how could you get someone to visit a specific link? Well, you could email it to them. You could post it on a Facebook wall. I mean, there's not a shortage of ways to get people to click on links, okay? You could also just send it as an HTML file inside an email. And if their email client has HTML preview enabled, it will automatically run it, because if it's a browser exploit, the same DLLs that, for example, IE uses to view that content in that web page, some of those same DLLs are used by your mail application preview client to look at that web page as well. So that's another avenue that you could take. But anyway, we're just going to pretend like the user clicked on a link. We're going to go over and play victim. And I'll just actually go to the files directory here. So that's where it is. Now we could also, go to it on port 80. So if we did a HTTP, we could do port 80. But what I want to show you here with this is the way you, the attacker, would know that someone has taken the bait is because it'll actually tell you, you'll see stuff start to happen over here that'll basically say, hey, they have taken the bait. So what happens is we can see that this guy's already trying to preview it. So if he goes in there, look at what just happened over here. You can see that that he's actually opened it, the directory, he's browsing the directory. So now that malicious DLL, as you can see, does not exist in here. It's not going to exist until I try to open or import one of these, for example, the Windows Address Book file. So the instant I double click that, right now, nothing's going on. The instant I double click this contacts file, so let's boom, double click it, you see the malicious DLL get loaded right there. And then the exploits actually launched at that point, or the shell codes actually ran and gives me my interpreter session there. That we can connect to, and now we control that box. So that's what DLL hijacking is. And if you think about it, I just demonstrated to you the attack against Windows Address Book. But if you think about that list that I showed you with all the vulnerable DLL hijack programs, now you have to consider, okay, this is possible against any, even if you don't try to do it against a Windows core program, all these Adobe products, even iTunes, Safari, QuickTime, um, Cisco Packet Tracer, Citrix ICA client. And a lot of these things you just don't update that often. Encase, which is the world's leading or most distributed forensic software, Ettercap, FTK, which is like second behind Encase, um, Google Chrome, Google Earth, and even for Google Chrome, it shows the latest as being vulnerable to it. So I mean, this would be like a fun weekend exercise, is to take a list like this and go through it and see how many of these you can POC DLL hijacking against. And it's real straightforward and easy. It really is as straightforward and easy as I just showed you.